good morning to everyone. The topic we are going to be discussed is the types of asynchronous sequential circuits, analysis and designs of pulse mode circuits, analysis and design of fundamental mode circuits, and designs of hazard-free circuits. So there are asynchronous sequential circuits. Basically, asynchronous sequential circuits changes the states and output values at a discrete instant of time which are specified by the rising and falling edge of a free running clock signals. That is, the memory elements used in asynchronous sequential circuits are flip-flops. But in asynchronous sequential circuits may be regarded as a combinational circuit with feedback. Because of the feedback among logic gates, asynchronous sequential circuits become unstable due to transient conditions. The instability problems imposes many difficulties on the designer. Hence, they are not commonly used as synchronous systems. Asynchronous sequential circuits have the characteristics of their internal states can change at any time when there is a change in the input variables. No clock pulses needed. Difficult to design. Delay elements, the propagation delay, must attain a stable before the input is changed to a new value. Have better performance but hard to design due to timing problems. So when the input variable changes the values, the Y secondary variable is not changing instantaneously. It takes some propagation delay. So in the steady state condition, the present state and the future states are not same, but during a transition they are not. So asynchronous sequential circuits, there are two mode of circuits. There are two different types of circuits. One is called as the fundamental mode and another one is called as the pulse mode. The fundamental mode operations assumes that the input signals changes only one at a time and only when the circuit is in stable condition. The input applied are level triggered one and not an pulse triggered one. In pulse mode of asynchronous sequential circuit, the inputs applied are pulse triggered, not on level triggered. The pulse width is long enough, then only the circuit is respond to the input. Let's see about the analysis of asynchronous sequential circuits. The analysis should be done in following ways. That is, the formation of state table with a variable or state diagram, formation of transition table, formation of flow table, formation of primitive flow table. Then we go for our design system. It follows some procedures. That is, derive the state diagram or state table for a finite state machine that realizes the required functional behavior. Derive the internal flow table. Derive the primitive flow table. Reduce the number of states if possible and performs the state assignment. Derive the excitation or transition table. Obtain the next state and output expression using K-map simplification. Derive a logic circuit that implements these derived Boolean expressions. These are the steps when we are going to design an asynchronous sequential circuits. So analysis procedure. Before seeing analysis procedure, let us start with the problems. That is, we have consider the asynchronous sequential circuits. It is given. From that we are going to analyze the circuits. So it is given a logic diagram. From the logic diagrams you have to derive the output equation, state diagrams, and all the procedures we have to follow that. That is, it consists of two feedback loops, one input variables x and two internal states. The internal state has two excitation variables y1 and y2 and two secondary variables small y1 and small y2. The delay associated with the feedback loop is obtained from the propagation delay between each input and the corresponding output. Each logic gate in this path produces a delay of 2 nanoseconds. The wires that conduct electrical signals introduce an approximately 1 nanosecond for each feet of wire. Thus, No additional external delay element is necessary when the combinational circuits are used. Necessary when the combinational circuits in the feedback path produce sufficient delay. So here first step 1, you have to form the state equations. So next state secondary equation, capital Y1 is equal to x into Y1 plus x bar into Y2. Then capital Y2, that is next state, is equal to x bar into Y2 plus Y1 bar into x. So we have to frame the state table. So the state table should consist of present state, input, next state and the condition of the state. So first secondary variable, what are the that is we have to consider that the secondary variable is a present state, that is y1 and y2, and we know that the input is x and the next state is, that is excitation, that is capital Y1 and capital Y2. From the above equation we can derive your capital Y1 and Y2. So here the stability of the state has to be considered, whether it is in a stable state or we have to say that it's an unstable state. So if your Y1 and Y2 are equal to capital Y1 and Y2, that is the next state, then we can call it as a stable. So here Y1, Y2 secondary variable is 0, 0. So in the your next state is also 0, 0. Then we can call that state as a stable state. If your secondary variable y1, y2 is, that is a present state, is not equal to your next state, then we can call that as an unstable state. So the stable states are marked as round. Then unstable state, if it is not equal, then we can call that as an unstable state. That is, for example, if you are having a secondary variable as 0, 0, but your excitation table, the next state is 0, 1, then we can call that as an unstable state. Then analysis procedures, how we have to frame that analysis procedure. So first you have to frame the tables. So consider the square for x is equal to 0 and y is equal to 0, 0, it is stable. So x changes from 0 to 1. The circuit changes from the value of y to 0, 1. The state is unstable. So the feedback causes a y to 0, 1. The circuit reaches the stable states. So then you have to form the transition table. So in general, if a changes in the input takes the circuit to an unstable state, y will change till it reaches a stable state. This is a transition table. So here next you have to frame the, next step is you have to frame the flow tables. So in flow table, a table whose name is which is named instead of the binary numbers. So we can name it as a 0, 0 state as A and 0, 1 as B state, and